Right. What's up, Ethan? Let me start the disc. There we go. They just started. What are you on this? Yo, smack the cat. Yo, what's good, dude? Smack it. Test. Oh, it is working. Vic is the best? Who's Vic is the best? What's up? What's up, Vic? I think you're the best too. Mm-mm. I do like your report card, dude.
That's dope.
Super dope, dude. Congrats on that. Yeah, dude. Try to get in science. Yeah. Well, you know, I'm here to help you guys in science. So you guys have no excuse to not be doing well. I'm not really in your Discord server. Well, you could be in our Discord server, you know. That's how we give out like prizes and rewards and stuff, you know. Come to the Discord server. It's a cool place. You also find out about all like the stuff we do. There we go. Okay, now that like 90%. It's okay. It's okay. Some people are in, some people aren't. All good. I'm a goofball. Yes. I was a huge class clown when I was in high school. My dad always had this quote. He's like, the number one important thing in life is to make someone laugh. He always said it also when like trying to find like a girlfriend or a boyfriend or whatever. Like, you know, as long as they make you laugh, usually everything else follows. I know you're Drip Ice. I know who you are. You're Woody. Woody, dude. Also your name. Bum, bum, bum. Is someone gonna challenge me? Yes, thank you, Equity. One sec. Let me challenge you real quick. Thank you for subscription, dude. Thanks, Sam. That's super dope. What does that put you at, dude? 16 months. Wow.
That's dope.
16 months. That's a while, dude. Equity. I'm challenging you to chess. Yeah. So some of you guys wonder like what happens is we have also a chess channel that people can join. And if you beat one of the other students, you also get the option to then challenge me at chess. And if I have time, I'll play against you. And if you win, you get 5 bond coins. So super cool.
Perfect.
I like Ethan, for example, you know, didn't even know how to play chess until he got into the server, and now he says he does know how to play chess. I think that's super cool. Chess is a very good game. Very good game to play. Smack, be nice to the be nice to the chat, please. There you go. Equity, I challenged you. The challenge, dude. Oh, it's okay. But wondering where the bond coins are, I'm like, always check. Always check. I get them out. Okay, cool. You don't need this. I have another monitor that I installed here, which I'm getting used to. Looks like this is the current state of my. Why is my? Oh, you know what this is? Oh, so interesting. One sec. Why is it outputting to that monitor? No. To go to. I think it's 1 sec. My audio settings change all the time. Every time I add a new monitor or a new display or something, it tries to make that the default audio device, which is like super annoying. I think it's what I want. Okay. Cool. Let's fix that. And then let me. I've learned a lot actually in the last 2 years of streaming with like all the different things you need to do in order to be able to stream. It's pretty cool actually. Let's see if this There we go. Okay, now it works. Okay, good. All right. Good. Always gotta make sure. There we go. Obama, thanks for the sub as well, dude. Another 16 months. Wow. Yeah, we've had a lot of cool. I appreciate. We've had Teacup just subbed. We had a lot of new subs come in. A lot of new server boosts too. I'm very happy about that. Oh, let me share my screen. Sorry, there, sharing my screen. But here we'll go to this is my current streaming setup. If anyone was curious, like what it looks like. I just added this additional. I got this inspiration from Bomby Boy. He had a 27-inch monitor and he flipped it vertically, which makes it like super long, but it's very useful for like, for instance, reading through all the chats when I have the Twitch going, because I have the Twitch chat going through, I have the Discord chat going through, and like it's hard to keep track of all the things if they're on like one monitor and I have to keep switching between windows. But now like I just have 2 separate windows so I can see it. Bomby Boy was saying like, yeah, I can't imagine the amount of heat that gets generated, and yeah, this closet does get quite warm because I'm running. That's like 4 monitors, 5 if you count the laptop. So yeah, it's kind of a lot. But it's okay because I also have like some pretty good like ventilation. Here we go, my ventilation. So inside the closet, I also have this big massive fan that just blows out all the heat. And this is actually a cool physics concept. You guys don't know. Someone screen, should I buy bits for a hype train? Yeah, dude, get the hype train, dude. Get the hype train going, dude. So hot air rises in physics. And so what this does, why I have this mounted at the top of my closet, is all the hot air from all the components and whatnot rises to the top, and then that gets like blown out. And in doing that, you create actually a vacuum. So what happens is because air is leaving the closet, there's a negative pressure that has to bring air in. And what it does is it ends up bringing in the cold air. Cold air sinks. So the cool air from the bottom of the room gets pulled into the closet. So it's how it circulates. It's a pretty cool. That's a pretty cool physics concept. Science and everything, dude. Science. Yeah. Okay, cool. All right, we don't need any. Equity, I challenge you. Bruh. You can't send any bits? Oh no, dude. Why is that? Why can't you send the bits? Bruh. Oh,
how's it going?
Yo, what's going on, Ramton? How's your Friday?
Much.
How's your Friday going, man?
It's going well.
Nice. I like that. Fridays are good. It's been a crazy week. I feel like this week has gone by like super like quick. Yeah.
Yeah, like this week was definitely busy for me, and last week was also super busy. But I think today, like, I didn't have anything anymore, so I think the exams are mostly done.
Right, all the finals. Oh wow, dude, 71 cheers! Thanks, Obama. Obama just sent us 71 cents. 71 cents to the Twitch. I appreciate that.
Hello.
What's up, Riplog? Good to see you, dude. And the Slimy want to come up here? Where's Slimy? Why do you become speaker? Slimy, I invited you. You can come up and speak if you want to talk to us, Slimy. That's the way to like kind of control like everyone that comes. Habib asked, "What are we playing today?" We're playing Roblox. Yes. Cool. Got that. There you go. Now Slimy's up here. Okay, cool. I was too late. It's nice. Okay, all good. All good. Okay, cool. All right, let's start off the stream. Welcome everyone to Office Hours. My name is Dr. Gold. I'm joined here with Ramton, and we're here to help you out with your math homework, science homework, any sort of questions you guys have, life, physics. Had a really fun time with the podcast yesterday with you guys. I really, really appreciate that. Like, I know Noise was like, I'm sorry I had to vent and dump all that. And I was like, no, dude, I love that, actually. It's worked out very well. Oh, I do have to drink. Thank you. Yeah, no. It was super useful. I actually had a couple students message me afterwards, talking about basically like they love the stream. They were like, oh, like that was like the best stream ever. Like, and I really needed that. And then even just like opening up to talk about like their own like issues going on. So like it's cool. I appreciate that.
That's good to like hear that everyone had a good feedback from that.
Yeah. Again, I think there's a lot of stigma, that comes with saying these things and whatnot, and it just helps for it to just be said. People are like, oh, okay.
Yeah, for sure.
I gotta move this water thing up. Have you messed with OBS yet, Ramton?
Not yet, but I was actually gonna get into it this weekend and mess around with it just to figure out some stuff.
Yeah, it's cool. I mean, it's kind of a pain sometimes to get things to work correctly, as like I'm finding. But there's a lot of power you can do with it, which is very cool. I like that. There's the customization, the rabbit hole of what you can customize, like just goes on forever. There we go. Okay, now I got the water dunk hitting at the right area. All right, let's see. Okay, anybody else?
I've seen some cool questions in the.
Yeah, let's go through them. Let's go through them, dude. We got some cool stuff coming up.
I like this. What's it called? Kepler's third law question. I actually wanted to see if the person who posted it, Shadow,
yeah.
Knows a little bit of physics, because you can actually derive it from Newton's equations. So I was like gonna show like a cool.
Yeah, no, let's do that. No, and I'm a big fan of, so in physics, there's a lot of different ways to solve problems, right? You can do things with equations, but then like you can also rederive the equations from like first principles, which is pretty cool. Yeah, here we'll go through Shadows. I don't know if he's here, but it's good to go through it regardless. I kind of like this one. And then Ramton, you can kind of explain how to come through it.
For now, just that make sure he's around, and then
here, yeah. Let me tag him. Let me tag him real quick. Because he posted this yesterday morning. Shadow. Go around. If not, we'll go to Teacup's question. All right. Oh, and Slimy's got a question too. I like that, dude. Here you go. Okay, so this is just this is a quadratic equation. This is messy. I don't really want to. Teacup just always goes to Wolfram Alpha, dude, and picks out like these ridiculous quadratic equations to be solved. Like why the hell do I want to do 884 over 245? Like no. That just sucks.
Is this like a randomly generated?
Yeah, it does. I'm pretty sure it just randomly generates them, dude. It's annoying. Did I grant you presenter? Yeah, you should be able to write already.
Yeah, right? I don't think you need to give me access like every time anymore. So that's
okay.
Good.
I just need to give it to you once. Okay, perfect. Okay, nice.
Yeah.
Teacup, you're around? Where are you at, Teacup? Where are you around? Yeah. Should probably check that first. It's kind of. I guess it's 8 o'clock for him. There's Habib. What's up, Habib? I'll load in the other question. A lot of people submitting questions, but not here. Riplaw with a good one. I like this one. Actually, I had like a 10th grader actually ask me about this. About which way does the alligator eat things?
I'm trying to learn 7th grade before I go to 7th grade.
Yeah. So what grade is this, Riplaw? What is this, Riplaw? What grade is this?
7th grade. Yeah, I got it from 7th grade.
7th grade. Okay, that's cool. You know, it's interesting because like this still confuses people in like 10th grade. Like it's all good.
Right.
All right. So anyways, okay, so here we go. Compare the numbers, pick the correct sign. Do you know how to do these? These actually there's a trick to these. Like, do you know what the trick is?
Kinda. So,
What do you think the trick is?
but I'm not sure honestly, since I learned a little bit about in 6th grade.
That's okay. Yeah, math is a continuous learning thing, man. Dude, you're gonna keep learning. Like, it'll seem like you're learning the same thing over and over again, but really they're just like making sure that you understand.
Alright.
Okay, what do you think the answer is to this one?
I think the crocodile on the right side.
Yeah, the crocodile, right? Yeah, dude, I love the crocodile. Yeah, yeah. So when we have this because when I hear like less than or greater than and whatnot, I always forget like which one it is. You know, even today I still do. Right? Yeah, totally. So yes, this is what I call like this is the crocodile. He's like munchy here. He's you know he wants to eat. The crocodile always wants to eat the bigger number, is what we say. Okay.
Okay.
So in this case, this could look kind of confusing because 7 looks like it's bigger than 1, but in reality, right, it's not, right? Yeah.
Yes.
-1 is less negative, so technically -1 is the bigger number. So in this case, yeah, you'd want to use this one. You want to use the less than there. Yeah.
Yes.
Yeah, cool. And okay, so here, let me expand on this. Let's make this like a little cooler so you can see like how things work. Do you know how to draw like so that's called an inequality, Riplaw. They call it inequality because it means like not equal. Do you know how to draw them on a number line? Like for instance, if I said X and I did this, do you know how like for instance I would draw this on a number line?
Yeah, I think so.
Okay. How do you think you do it? Show me.
So, so on the left side is negative, and then the right side's the positive.
Mm-hmm.
And if you decrease, it goes to 3. The left side goes to 3.
Uh-huh. Yeah, getting smaller definitely goes to the left, right? How would I say this in like in English? What would I say? X is what with compared to -3?
Is less than?
No, this is X is greater than -3. Because again,
Oh,
let's I
What
know.
is this?
It confuses. No. This one confuses me all the time. Okay. The way to think of this is, do you see how, again, the alligator? The alligator is eating the bigger number. Which one's the bigger number here?
X.
X. So X is greater than -3, right? It's the bigger one.
Mm-hmm.
Does that make sense?
Yes.
Okay. So now in terms of the number line, right? Usually like I draw this as like an arrow this way, like how do I draw the arrow? This is an important thing, important skill to know.
I don't get what you're saying.
It's okay. So here, let me show an example of one. Let me do it on this one. Let's say, for instance, I want to show that X is less than 5, okay? What I'm going to do is I'm going to draw a circle here at 5, right? And then I'm going to draw an arrow here going all the way to the left. Because do you see how this is saying X, like, all the numbers that are less than 5? So if this is 5, all the numbers less than 5 are all over here.
How did I forget that? I learned that like 2 days ago.
Yeah. It's okay. It's all right, dude. I forget sometimes to, like, put toothpaste on my toothbrush. Like, I think the other day I put soap on my toothbrush, and I was like, uh-oh. That's not good. COVID kind of, like, messes with the brain. But, yeah, and there's a difference here. Like, what would change here, Riplaw, if I put a equal sign underneath? If I said X was less than or equal to 5?
So it could be equal to 5, or it can be less than 5.
Right. So if we don't have the line underneath, right, that's just less than. But if I do have the line underneath, that's less than or equal to.
It could be equal.
Right. Okay. But then what changes on my diagram here when I draw this? How do I change that? What is going to look different?
Very bad memory, bro.
It's okay. It's all right. You see how this is an open circle, right? When we have it just being less than. If you also have the
Yeah.
equal, you need to make this a solid circle, okay? That's what you have to do.
Oh,
You have to fill in the circle.
I got the worst memory in history right now.
No, you don't. Don't worry. There are people with
Again,
way
the
worse
Guinness
memories.
World Record.
Also, like, you know, like, okay, so memory for things isn't necessarily you know, you learned this a couple days ago and whatnot, but in order for it to that's short-term memory, right? Because you've only done it like once or twice. Once you've done this for a while and you've practiced it, things start going into what's called your long-term memory, which in that case you remember things a lot longer, right? Like, you know what your name is. You remember what your name is, right? Because you've known your
Yes.
name for a very long time, right? But let's say you met someone like yesterday and like you saw them again today. Would you remember their name?
Probably, but
Probably not, right? Yeah, I don't. I'm the worst. I meet so many people in my industry and whatnot that like I don't ever remember people's names because I only see them like once, and then I see them a couple days later or weeks later. I'm like, oh, I only saw you once. But for instance, your best friend, like Riplaw, who's your best friend?
I don't got one.
You don't got one? Well, you must have a close friend at least. It's okay. I say all my friends. Yeah, but you know their names, right? You know your close friends' names, right?
Yep.
Right? Because you see them all the time. That's practice. That's repetition. It's the same thing with math. In math, you know, you may be like, oh, I'm so dumb, I don't remember this. It's okay. You've only seen it once or twice. It's only after you've practiced and seen it a lot of times, that's when you're going to really remember it. And this is why, I know you hate it, but this is why your teacher gives you homework. Like, homework is so that you do something repetitively, and then you're more likely to remember it.
They just give us a piece of paper and give us one period to do it, and then they go on to the next lesson.
Yeah, it's not the best. I mean, ideally, again, and like, you know, there's all sorts of commentary on like how people teach and whatnot, but how I teach, and again, how we're kind of going to do this in the Discord is that like, we'll go through a question and then I'll give you another one that's related to it because I want you to repeat it. Because the more times you repeat a concept, the more likely you are to remember it. Okay? Kind of a cool thing. All right. So knowing that, so here, how do you think I would draw this? How would I draw this? X is greater than or equal to -3. How do I draw that on the number line?
Okay. You first circle the 3.
The -3, right?
And
Am I
then
going to do a closed circle or an open circle?
open circle since there's no equal sign under the greater.
Yeah, so you're going to do an open circle because there's no equal sign underneath. Okay, and then which way is it going to go?
Right way since it's positive.
Good. Because, yeah, there's a trick to this. So if I say this, right, how do I say this in English? X is what in compared to -3?
X is greater than -3.
Good. Right? So numbers that are greater than -3, right, are here to the right. So you're just going to draw an arrow going all the way here to the right like this. Okay? You see that? Yes.
Yep.
Okay, very good. Let's make something a little bit trickier. Again, this is the whole practice thing. If you practice it, like, you're going to get it more. I know it may be like, oh, man, I got to do another one. It's just like, you know, but it'll help you. Like, trust. Okay, let's say we have X is less than or equal to 1. How am I going to draw this on the number line?
You circle the 1 fully
Good,
since there's a equal sign,
good,
and then you do it to the left side
good.
since
Yes,
it's less than.
because it's all the numbers less than 1. Yes, good. Okay, good. Very good. All right, last one. Last practice one, I swear. Okay, let's say that -2 greater than or equal to X. What happens when this happens? This looks weird, right?
Yes. it
Yeah,
is.
he's like, yes, it does, right? Yeah. Okay.
We don't know what the X is because it could be
We don't.
any number.
Right. So let's see how this says in English, right? What do I say? This is what with compared to this? -2 is what? Is what?
Is less than equal to.
Well, let's think.
Equal
Which
to X.
the alligator eats which one? The big one, right?
Yeah. So X is less.
Good. So X is less. So -2 is then
greater than.
Greater than
Negative 2
is good. Greater than or equal to x, right? That's a weird statement.
Yes.
Because usually we say x is greater than or equal to something, but now we're saying the number is greater than, to x. Okay?
caught me off guard.
Caught me off guard. Yeah. Well, yeah. Again, this is what they would do to try and trick you. Like, again, I know what the teacher's going to ask you to try and trick you up. This is what they do next. And that's the advantage of doing this, is that, like, if you ask me a question, I know what they're going to do to trick you with the next thing, so I can show it to you before you get tricked. That's the whole point.
Alright.
All right. So this is kind of a weird thing to draw, right? -2 is greater than or equal to x. I'm just like, what? What does that mean?
Yeah.
Well, you kind of said it yourself. If -2 is greater than x, then x is less than or equal to -2. You see how those two statements are equivalent? I could also say x is less than or equal to -2. Okay?
Yes.
The way to write this, Riplaw, because again, I don't like writing things like, because I would have like no clue how to graph that down here, right? Because I'm used to having the x doing things. You can switch the order of these as long as you also switch the order of this. So this statement right here, Riplaw, is the same as x is less than or equal to -2. Do you see how the alligator eats the -2 in both cases?
Yes.
Okay, this is an important thing. Anytime you're getting confused, like, you can always switch it so that the x comes first. Just make sure you also switch the sign of this. Okay? Because now you know how to graph this. How do I graph x is less than or equal to -2?
A -2 is like a circle. You circle it,
Good. Solid circle. Yep.
and then the arrow goes right. I think.
Well, let's say
Not go with the alligator.
it's so yeah. So here's another thing. So here's another trick here, Riplaw. As long as you have the variable first, x, whichever way this arrow is pointing is the direction that the arrow will point here as well. That's another trick. Yeah. Which way is the arrow pointing?
Right way.
No. Arrow here is pointing to the left, right? You see that, Riplaw? Do you see how this is pointing to the left?
Shows me. Yeah.
Yeah. So on my graph here, I'm going to draw with the -2, and I'm going to draw the arrow going here to the left. And this should make sense, right? Because you see how x is less than or equal to -2? All these numbers here are less than or equal to -2. And, the opposite, like, statement is true, where, like, we say -2, right, is greater. See how -2 is bigger than all the x's? This is bigger than everything else down here. That's why those two statements are what we call equivalent. Like, they're the same, saying the same thing. It's like if I said, the helicopter is above the car, but I could also say the car is below the helicopter. In both cases, we're describing helicopter at the top, car at the bottom. It's the same here with the less than or greater than. You can flip things. What you can. But here's the main thing I want you to take away from this, because if she ever asks you to graph things on a number line, this can get confusing. Always make your statement so the x is coming first, and then whatever direction this is pointing, that's the direction of the arrow. Okay? So if I had x was greater than 1, right, that would be a semicircle here. Which way would the arrow point?
Okay.
Yeah, which way would the arrow point here, Riplaw?
Right.
Right, good. Nice, good job.
Nice.
That make more sense? Make more sense to you, Riplaw? I hope it does.
Yes.
Yeah, very important concept. So yeah, I'm glad you asked that question and whatnot, but like, Slimy says I could have helped you. Yeah, well, yeah, friends can help you. But always come to me as well, because like, I know the next thing you're going to have to learn, and I can teach it to you before you get like sneak attacked on it, Sweet. Okay, sweet. Bond coin to Riplaw. Nice. Good job, dude. All right, let's see. Questions. Okay, Teacup's around. What's up, Teacup? You want to do your question? What's up, Monsieur Teacup?
Hi,
Yeah.
yes, hello.
Hello. How's life, dude?
Mediocre.
Mediocre. Don't worry, you're getting that desk soon. I'll have a letter for your parents by this weekend. I've been like taking care of a lot of things, but don't worry, we're getting you that. We're gonna get you the desk, dude. That will be my accomplishment. Will be getting someone's parents to agree to me to send them a desk.
Hey, you can send me a desk.
Yeah,
My parents
Rampton
will
says
too.
Rampton's like, you can send me whatever you want, you know? It's definitely easier with the college students for sure, because they have their own addresses. You know, my parents would be fine, maybe. Yeah, see, here's the thing. You think they would be fine, but until you ask them. It's always the ask. You gotta ask. I always think about, like, you know, how we could get, like, more college students in this Discord. We tend to, like, get a lot of, like, middle school and high school students. Which I'm cool with, because honestly, that, you know, as we were talking, Rampton, that is like the demographic that probably needs the most like help. I think effectively, if we're trying to get more kids into STEM, right? It's getting them at middle school and high school.
Yeah, that would make sense. I feel like it would be nice to have the because like I feel like
Trying to get
even
rid of
when I
that.
was like first year and second year, I tend to realize that a lot of people still feel lost
Yeah.
because I mean, and it's because they didn't get the help earlier on.
Mm-hmm.
But I mean, you know, people will always find the Discord channel at like different stages. So like, I feel like still for like first and second year students in college, they would still be able to like use it really well. And I feel like the exposure to like some of the later stuff,
Yeah.
would like kind of give some ideas about what people would learn. And then what we could do is that we could like split it into like different days, right?
Yes.
So like it
Yeah.
would be like middle school like Mondays, and
In
then
middle
high
school
school like
Mondays, high school Fridays, or something. Yeah.
yeah, something like that.
Kind of like
And
what I
then
did, what I already do with the gaming. Yeah, and that it. I've just been waiting to hit like the critical mass of where I need to split.
I was
days.
trying to kick out the middle schoolers.
No, I like the middle school. Like, again, so you know, that concept there, you know, that was a middle school concept, doing less than or greater than and whatnot. You know, it's a relatively simple concept if you're in high school. But Rampton's right. Like, some people just don't know that. Like, they're just still lost. They're just like, oh, I just never really learned it, and they're afraid to admit that they don't know it.
Well, here's my question. What is my question on the scale?
What's your question on the scale? What do you mean?
On
Oh,
the scale of middle school to high school.
it's like early high school. Habib says, okay, what's your question? What's your question, Habib? Did you post a screenshot of it? You got to post a screenshot in the thing for me to
I
see.
like Abib's question because he just put Collat's conjecture in here,
Where did he do
like-
that? Where did he put it? Where did he put it, bro?
just in the help screenshot.
Oh, F event. Oh, okay. Yeah, what's the question though? Yeah, okay. Yeah, what's
Yeah,
the
the question. But this is called the Collat's conjecture, and it's like pretty much you would always end up with one, and it's
Uh-huh.
like prove that this happens for every like
Guys,
integer
hear me out.
or like positive integer. But then
Oh,
the
I
thing is
see.
like the thing is like this is an unsolved math problem. As easy as it this has been 150 years plus unsolved problem, and it's like a curse in the.
Is this like Fermat's last theorem? Like the whole thing where it's been like unsolved for like 200 years or some shit, and there's like $1 million X prize for it.
Yeah, I don't think Fermat's last problem was solved. So
It
like,
was in the last decade. I remember the whole video on
Yeah.
it. Like, he ends up like having to divorce his wife or something because like she's like, you don't have any time for me, and he's like, I only have time for math.
Sounds like a her problem.
It's a very, we watched the video, I remember, in middle school and whatnot, and it was cool to see this guy just like going almost crazy to solve this like unsolved math problem for the last 100, 200 whatever years. And yeah, he ends up having to basically like disregard everything, like his relationships, his health, like everything, because he's like, I'm gonna solve this.
Does he solve it?
He does solve it at the end, but it's like, at what cost?
$1 million.
Yeah.
I don't think I don't know if Fermat's last the theorem was part of the Millennium questions.
Was it? Was it?
But we can talk about the Millennium questions also, because I actually think that's a cool topic because it's unsolved, so we don't even have to like get into like, oh, like what's the proof for it, because it's unsolved problem. So we can talk about like what they actually like mean.
Yeah,
Why
what
should
they
I
are, what they mean.
accidentally
Yeah.
solve it?
Yeah, this was for Ma's last theorem. For any integer greater than 2, a squared plus b squared plus c squared, basically. Yeah. So you can't do a cubed plus b cubed equals c cubed, or a to the 4th plus b to the 4th equals c to the 4th. Like, there are no positive integer solutions for this. Yeah. This is cool. Like, you know, I always wonder sometimes, I'm like, wait, how do math grad students do math? Like, haven't we solved all the math? And it's like, no, we haven't. You know? But where's the guy that solved it? There's a whole video of this guy. Yeah, this dude. This dude.
Dang, my
This-
person just got disregarded.
We'll get to yours. I just think this is a cool little side topic. What was his name? His name was Andrew Wiles. Yeah.
I kind
At
of want to touch
Oxford.
more on this in Golden Hour.
Yeah, we should. Yeah, we should do that. We should have one of our topics at Golden Hour just be like,
Okay,
let's
we'll
go
set-
over like
we'll set up one-
what
Yeah,
are
we
the
still
what are
have
the
an idea.
millennial what are the X Prize? Is it the Millennial Prize or the X Prize? What's it called?
I think the Millennium.
I know
Prize
Google has a whole thing, right? The Google X Prize or something. Like they have some also things. I think one of them is turbulence, right? If you just solve
That's part of the millennial questions
that's
as
the
well, which
the
is
yeah.
what's it called, the
Hey, what game am I
Navier-Stokes
playing on Roblox today, by the way?
Navier-Stokes equation.
Yeah, the Navier-Stokes existence. Yeah. This is the fluid one, which I have relates a lot to what I did in my PhD. I did a lot of turbulence and transport, and like turbulence is
Oh,
a very
wow.
beautiful. It's a beautiful thing. It is
Yeah,
like
it's
it's cool.
that's something I want to definitely study more.
Yeah, it's because it's like the most important thing that we just don't understand. You know,
Yeah.
I think they call it like the number one. Who is it? Fuck, what's his name? Very very famous guy in physics. Mr. Oh my god, dude. Why am I blanking on this guy? He went to strip clubs all the time, Caltech.
Why do you remember that?
Because he was kind of a badass in physics. Oh man, one sec. What strip club? I'm gonna look up strip club physicist honestly, because that's how I know him, which is bad. But Feynman. There we go. Jesus Christ.
Oh, Feynman. Oh, okay.
Yes.
Yeah.
Feynman ends up saying, yeah, he was a very cool guy. He's like a very like Mad Men
Yeah.
type guy.
Forgot he went to Caltech.
Yes. He said, I remember you saying, yeah, this is great, dude. The story goes, he once said that if you were allowed to ask God 2 questions, they would be why quantum mechanics and why turbulence.
Okay.
And he said God would be able to answer the first one, but not the second one. Yeah. He said it was like the number one unsolved problem in physics is turbulence. It's very cool. Yeah.
Yeah, I mean, the best we can do is perturbation theory,
Right. Yeah.
which
Perturbation
is
theory.
still pretty good.
And oh, that brings me back, dude. Perturbation theory. Wow, that's a throwback. All right, nice. Let's see. Oh, okay, teacup. Yeah, we should do. I don't want to solve these because this is just the quadratic equation just on crack.
I'm doing the quadratic equation in math.
Yeah. Okay. Well, let's try to think of a cooler question for you to do. Because this is just like plug and chug. It doesn't really help you. Do you know how to complete the square? Actually, that's a good one. Do you know how to complete the square?
What'd you say?
You know how to complete the square?
Not that I think of.
Okay, I'm gonna teach you how to complete the square because it's actually a very useful thing to be able to complete the square. You already know how to do the quadratic equation. I don't need to teach you the quadratic equation.
How do you know?
Because I've done it with you like a gazillion times on this.
Okay, he's right.
Okay, here we go. We're gonna go real quickly over completing the square. Completing the square is very useful, especially when you have something when you get into what we call conics sections. Conic sections has to do with like parabolas, hyperbolas, ellipses, like all these like weird shapes, and it actually, you know, there's a whole other lesson on this. It comes into like having like 2 cones and then like slicing them at like different ways. They create cool graphs. There's a very cool theory behind that. We can do it. We can
That's
split.
actually the beginning of differential geometry as well.
Is it?
That's what-
Okay, see, this is
yeah.
where like, this is the big picture I don't know. I'm just like, why the fuck are we learning conics? And you're like, okay, it's
Yeah, like this is the beginning. It kind of connects later on, but it's like, yeah, it's cool.
okay, cool. Again, more topics we could go through, but here we'll just go real quick so I can run through everyone's questions. If you have an equation, for instance, teacup that looks something like, let's say like 4x squared plus, I don't know, 24x minus 12 is equal to y. Okay, this is something that we could graph, for instance. Okay, but
Yeah.
it's hard to graph it in this form. So a lot of times, what we want to do in order to graph this, because this is what's called a parabola.
Well, why don't
Um,
we do? Yeah.
we-
So why don't we?
We want
do
something like
negative-
this: x minus
we
h
do
squared plus
negative
k.
24 over -24 over 8.
Over 8? Why are you dividing by 8?
I don't because 4 times 2.
4 times.
I don't know.
Okay. Well, all right. Here's the thing. This is called the standard form of an equation, and then this is called vertex form. All right. The reason why this form is nicer is because if I have a parabola that looks something like this, it's always going to have a vertex like the bottom here at h comma k, and then that's how I can graph this. It's super super nice. Okay. So what I'd like to do is to turn this into something that's y is equal to x minus h squared plus k. However, as I have it now, I have x squared and x, right? Here, you see how x is only showing up in one place and it's underneath the square?
Yeah.
I'd like to be able to turn this into something where I just have x underneath a single thing being squared, all right? Trick to doing this is to always, first of all, try to factor out something out of all of these things such that this coefficient is just 1. So what can I factor out of all the terms here?
4.
4. Good. All right, I'm going to pull 4 out. So this is going to be x squared plus 6x minus 3 is equal to y. Okay. Next trick is I'm going to take this middle number here. Okay. I'm going to divide it by 2, and then I'm going to square it. Okay. So what happens there? What happens when I divide 6 by 2 and then I square it? What do I get?
9.
9. Good. Yeah. Okay. So now I have 4 x squared, and then sorry, I'm blanking here for a second.
What is it?
Yeah, sorry.
And
It's
then-
plus 6x, right? And then it's gonna be plus 3 squared minus 3. But then, and this becomes kind of a personal preference thing where you put the next one. I'm gonna put the plus 3 squared here as well. Is what I'm gonna do. Sorry, I'm gonna put minus 3 squared. Sorry. You see how I added 3 squared and I subtracted 3 squared?
Yes.
That's legal. Anytime you just add a number and then immediately subtract it, you're not changing the equation, so that's okay. All right.
Then why even add it in the first?
You'll see why. Okay. Because this is something special. Do you know what this is? Does this look special to you?
And the thing that what they call it, the vector thingy.
Not a vector thing. Here, Mr. Bean's gonna wait for you. What is it?
I hate Mr. Bean's evil. I don't like him.
It's okay. This is a perfect square trinomial. Is what this is. So
Oh dang it!
yeah, okay. If I have, for instance, a plus b squared, that's equal to a squared plus 2ab plus b squared. You see how this kind of looks like this?
Yes.
Yeah, I have something that's squared, something else that's squared, and then I have 2 times that. You see how this is 2 times x times 3, which gets me 6x?
Oh my God, he's right.
Yes,
He's
it's-
amazing.
2x times 3, right? See how
Yes.
that's the same thing? Okay, cool. So I can rewrite this whole thing here, okay, as what?
Four x squared.
No, not x squared. Oh.
Four 1. I don't know.
What is A? What is A in this whole thing? What's A?
A is x squared.
No, A is X. Because see, it's
A is x.
A squared, X squared.
Oh.
A is
okay,
equal to
so
X. What is B equal to?
B is equal to 3.
Okay, so how can I rewrite this whole thing? I can rewrite it as A plus B squared.
X,
Yes, good.
x plus 3 squared.
Yes, dude, good. Okay. And then don't forget, we still got our leftover stepchildren here. -3 squared.
Can we just kill them?
Nope, no
Like
killing
sell
stuff.
them off with money?
No, no, no. We love our we love our
Listen, they're just stepchildren. We
They're
can
still
sell them,
people.
get some organs. We can get money.
What's with the organ selling, dude? Do you have like a secret thing you sell organs with? All right, cool. So, last thing is let's simplify this. So this is -3 squared. This is the same thing as -9, right? -3 -9 is just gonna be -12, right?
Yes.
Okay.
-12.
Multiply through. So I get 4.
Can we simplify this?
We're getting there. X squared minus 48 equal to Y. Okay. So then that gives me my final expression here, which is Y is equal to 4 X plus 3 squared minus 48.
Oh my god.
Now we're in vertex form, okay? So here's a good question, though. The next follow-up question here. Now that you had... So this is the big thing here, guys, is that this equation here is the exact same as this equation up here. We've just, like, reformed it. We've just reordered it in a certain way, yeah. And the reason why we did that is because this ends up looking like vertex form, which is a good form that I like, that we like. Because what did I tell you, for instance, H and K were? What were those in terms of the graph?
The asymmetry line.
It's the coordinates. It's the coordinates.
The minimum.
The minimum. Well, the minimum if it points up, and then but
the
vertex.
bottom of it.
Vertex. It's the vertex. It'll be the
My
minimum.
brain-
It will be the minimum, teacup, if this thing points up, if this is positive. But it will be
No,
the
If
maximum.
it's negative, it's maximum.
Good, because it points down.
My
Happy-
brain isn't working today.
It's okay. Mine is fucked up too. You're good, dude. Don't worry. All right.
I got a 100
So-
on my civics test.
That's
Good job.
To become a U.S. citizen.
Okay. What is H and what is K? Let's get the vertex for this thing.
H is 3.
Nope. It's X minus H.
Well, let's just the H is -3.
Yeah. You see how this would have to be -3 for it to be minus -3? That would make this positive.
Yes.
Right. So
And
this is
then-
-3. And then what is K?
K is 48.
No. It's plus K. And then this is what?
-48.
-48. Yes. Very good job, T. Now you know how to complete the square. We'll see if you remember it.
Yeah,
That's always the
I
question.
probably won't.
Well, I hope you do.
My brain wasn't
Uh,
working today.
Hikaru, yes, you can be a speaker. Yeah.
I think I punched a kid.
Don't punch a kid. Don't do that. Also, thank you
They
for
got in
being
my way.
thank you for
I
being
know.
our stage monitor moderator yesterday. I was gonna say,
weird and should never talk to himself and eat a lot of beans.
What? Eat a lot of beans? Excuse me. What? What? What?
Do
But
you like my profile picture?
it looks like a person
That-
who's missing a nose.
That's the chest plate. Oh, when I accidentally
Yeah.
moved to the audience. No, I accidentally moved to the audience.
You move into the audience? No, bring him back up. Bring him back up. Bring him back up.
I moved.
Yeah.
Hey, why did you do that? You're a mean.
He messed up. He messed up. Yeah, your
Yeah.
your profile
Chest
picture is
player.
missing a nose, dude. What happened to the nose?
It's Nick
Isn't that-
30.
Isn't that the chess player?
Yeah, I am a chess player actually.
Well, Hikaru Nakamura, I think, is like one of the. He's a famous chess player. He's a very famous.
He's one of
chess
the
player.
better ones who is
Hey, Dr. Gold, do you play on
contested.
chess.com?
I don't play on chess.com. A lot of people ask me if I do that, and really, maybe I should. I just, I don't.
I
already
Raise
have
your
s-
hand if you play on chess.com.
A couple people do. A couple people definitely do in this server. Maybe I should organize to have you guys like add each other or something. But you know, you could also
I
play
think-
chess against each other in the server.
I think Hikaru is contested with Magnus in
Is
like
he?
who the best chess player is, but it's like in certain categories.
If me and
Yeah, so I'm like the best in
I
everything.
think Magnus still wins the overall though.
Obviously, yeah.
but didn't he
Magnus-
retire? He's not playing anymore, right? Or he's done?
No, Magnus was taught by Gary Kasparov, and Bobby Fischer taught Gary Kasparov, and you know who Bobby
Yeah.
Fischer is?
Of course,
like,
there's a very good film about him. He had a kind of a troubled
know.
life though. You know, it
It's
happened.
called Pawn Sacrifice.
Who-
No, no.
Guys,
I thought there was a
Chess
movie
is
called
the best player.
Chasing Bobby Fischer. Was that a movie, Ramton? Do you remember that?
Let me look it up.
I'm sure.
Mommy,
Yeah, I think it was.
Chasing Bobby Fischer.
Chasing Bobby Fischer, I think is a movie.
You're such a smarty pants. Yes, he is.
Yeah. Sometimes. I get
Wait.
pretty
So what
dumb
are we
on the
playing on
weekends.
Lookout today, by the way?
No,
We're
it's
gonna play
searching
Doors.
for Bobby Fischer.
Searching for
Okay.
Bobby's Fisher. That's what it is. Okay.
Why is it always doors?
Well, because
you
Ethan
smart?
bought the change the game thing on Wednesday, so I gotta let him.
Dr. Gold, are you smart?
I'm decently intelligent.
Thanks
Yeah,
for having me
I
on
do too.
Fortnite, by the way.
What's up? What'd you say? What'd you say, Hikaru?
Thanks for having me on Fortnite.
Oh, you're welcome, dude. Yeah, come play Fortnite with us on Mondays. Okay, Ethan, you want to do your
Bye-bye.
question? I see a bunch of triangles here.
Yeah.
Okay.
See, I'm telling you, it's hard.
Fuck. Okay, what is this?
Maybe we should just lower down the difficulty for this thing.
No, it's okay. We like the difficult stuff, you know. It's fun to stretch the brain out. Okay. The sides X, Y. Wait, where the fuck is Y? Okay, there's X, Y, sorry. All right, so this length here is 2. YZ has a line. Okay, this is equal to 3. And then XZ is equal to 4. Okay, cool. Awesome. AMBP. Okay, so this is parallel. This is parallel, and this is parallel. Well, whatever. They're parallel to the sides. Okay, I understand that. That's okay. All right. So, okay, so AP. So this length is equal to QS and BT. These are all the same. What is the length of AP? Oh man. Ramton, do you have any idea about this one? You're the geometry guy.
I'm just going back and I'm reading the question.
Yeah,
But
just yeah.
I like the question.
Okay, good. Yeah, this is the challenge question for Ramton. Let me teach the number line stuff. You can teach the hard stuff.
Oh, okay, so you have a bunch of similar triangles.
Mm-hmm. Inscribed triangles, right? Are they similar or inscribed? I think maybe, yeah.
Like similar, yeah. So the parallel to the sides X, Y, Z, so that AP, QS, and BT are the same length. Oh, okay. The length, what is the length of AP? Okay. Okay, so the ratio, I think we just have to do a comparisons of ratios with these ones.
Mm-hmm.
So I just have to write a bunch of stuff down. So AP, like the triangle APM is, what's it called? Is similar to triangle XYZ, the big one. So then AP over AM is equals to XY over XZ. And then which length are we looking for? AP? Yeah. And then TB over MB is going to be 3 over 4.
Over MB, because yeah, I see this. You're talking about this triangle right here, right?
Yeah, so that triangle, we want to compare that to the big triangle XYZ.
Right,
And we also
compared to
want to
this.
compare APM to also XYZ. And we want to compare MSQ to
Uh-huh.
XYZ. And
Uh-huh.
then from the, I don't know if that one's necessary, but like the ratio of, yeah, once we do that, we're going to be able to find. I don't know whether all of this information is one of those one of those questions where you have to use every piece of information, or
Yeah,
some of it
are
is
they just giving us like a bunch of like red herrings, right?
yeah, to just kind of throw you off.
Yeah,
I'll just
right.
write you
Yeah, just
like
yeah, right. You can write stuff, right? Write equations.
yeah. I think this is gonna be one of those questions where I like go the long way and be like, oh yeah,
Yeah, and then I'm gonna tell you, Ramton, I'm gonna be like, no, they're parallel, or like they're equal.
no, I think this time so AP over AM. This is 2/4. And then TB over MB goes to 3/4. And then the side SX is equals to, oh yeah, I think we need to do SX is equals to AM, and QZ is equals to MB, and then SQ over, or something over SQ would be better. And let's go MS maybe? Yeah, MS over QS is equals to 2/4 also. Okay. So, and then these comparisons, we can replace some of these. I want to try to get like an XZ out of all these stuff, essentially.
Yeah.
But,
well, we know what X. Well, X. Oh, you mean an expression for XZ in terms of everything else? Because XZ we know is 4.
Yeah, like XZ is SX plus SQ plus QZ.
Mm-hmm.
But then this is also MB, and this is also AM.
Yeah.
And so this is.
This whole side is this.
Oh yeah, and then MS is also AX. Oh god, this is gonna be. AX is also AX. Okay. And then TM is also YP. Okay.
Oh,
so
I
then,
see. Yeah, because this makes a parallelogram. That's cool.
Yeah. So then XY is AX, which I'm instead of AX plus AP plus PY,
Mm-hmm.
and then this is TM AP that we want, AX, which is MS.
MS, yeah.
Okay, now let's.
Oh,
let's
and then we have the
write-
relationship here between MS and QS.
Yeah, like let's. Yeah, exactly. So let's write all of this. So so MS, or I'll do it the other way. QS is equals to 2MS. And then, so AP we don't have. SQ, what is the relationship? SQ, oh, we just did that. Yeah, AM, what is AM? AM is equals to 2
AP. Mm-hmm.
Okay. And then YP, which is TM, is going to be, did I not write an equation for T? So TM, let's say over, I have to use the right, I think over MB would make the most sense. It would be 2/4 also. So then MB is equals to 2TM, which is 2PY.
Okay.
Okay. So now XY over, I feel like I'm complicating this, but this is like just pretty much about finding the right way of expressing everything in terms of the other thing.
To get everything cancels, and then we can hopefully just like divide things out.
So then XY, which is MS. So X1, which is MS. MS was AX.
AX, yeah.
Or yeah, there's another way of representing.
Or two. It's 1/2 QS. Right.
Well, MS is 1/2
QS.
QS. Yeah, that's the one. 1/2 QS, and then plus AP. AP plus TM is
Same thing as
1/2
PY. Or 1/2 MB.
1/2 M.
Right.
X.
From here.
I'm right. Oh, I'm writing the wrong one actually. Sorry. I was trying to simplify this. Yeah, SX, which is AM, is gonna be, what's the relationship with AM that I wrote down? Oh, AM is 2AP. Yeah, so this is 2AP plus SQ is 2MS, which is 2AX, but we don't have that. 2M. Q. Oh God.
Ethan, where'd you get this question, dog?
No, I feel like this is a one of those that you like have to think about, but I feel like I have all of the information I need.
Uh-huh.
But okay.
Here, let me help Bob with this question before he has to go real quick. And then
What's a good one?
here, let me do this real quick. And then we'll come back to yours, Ethan, because yours is difficult. let me make sure that people don't fall asleep for me going through questions. Yeah, thank you. Someone mute him. Yeah, it was very loud. Okay, Bob, what's up? Come up the stage real quick. Let me get through these real quick. Oh, good.
Hello?
What's up, Bob? Which one do you need help with?
159.
Okay, cool. All right. For the following, graph the functions on a calculator. Draw the secant line that connects the endpoints. Estimate the number of points C such that. Okay, cool. This has to do with this is called, I think, the mean value theorem. Have you heard of this before? Right? Yeah. Okay.
Mm-hmm.
So this says that mean value theorem says is if I have a function that looks something like this, and I have 2 points, you know, what is it? A and B, right? That the average slope between them, right, has to equal the instantaneous slope at some point C. Okay?
Yeah.
All right, great. Okay. So in order to do this, let's do f of B minus f of A, right? So that's going to be, oh, ew. Okay, whatever. That's 2 squared cosine of 2 pi minus, I'm doing this part first, right? Minus 2 squared cosine of negative 2 pi. Okay. Which this is just going to be 0. Right? Cosine of 2 pi is the same thing as cosine of negative 2 pi.
Wait,
Do you-
cosine of 2 pi is 1.
Yeah, but subtract it from
Oh.
each other, it's gonna be 0.
Yeah, I see.
Yeah, cosine of 2 pi is 1, but cosine of negative 2 pi is just going around the other way. It's still 1, right?
Yeah.
Okay, so this is gonna go away. Goodbye. All right, so whatever. Okay. I don't even care what b minus a is at this point. I'm just trying to find where the derivative of this is equal to 0. Does that make sense?
Mm-hmm.
Okay. So, how do I find the derivative of this? This is a good one. X squared cosine of pi x.
The multiplication rule thing.
Yeah, this is the
Product
product rule, right? So we're gonna do the derivative of the first, 2x, times the second, cosine of pi x, plus the derivative of the second. What's the derivative of cosine of pi x?
Negative sine pi x.
Good. So that's negative sine of pi x.
Oh wait, negative
Yeah.
sine pi.
No, it's negative sine of pi x times pi. Yeah, don't forget the pi, right? Because this is
Yeah.
a chain rule now, right? So yeah, this is gonna be negative pi sine of pi x times x squared. Okay, plus minus. This makes it a minus. Okay, okay, and then I want this equal to 0, right?
Mm-hmm.
Okay. I'm gonna move this to the left. All right, so I have pi x squared sine of pi x is equal to 2x cosine of pi x. Okay.
Mm-hmm.
All right. There's an easy solution here. So there's a trivial solution. What happens if I just... You should always check this, by the way. Because you see how, like, my next step would be to probably divide by x, right?
Yeah.
But in doing so, you have to be you have to be careful to make sure you're not removing the solution when x could be 0. Okay? Because if you do this... So, for instance, if I say, like, x squared is equal to x, right? And I divide both sides by x, you see how I just get x is equal to 1?
Yeah.
But in doing so, we forgot the solution where x could also be equal to 0, because 0 squared is also equal to 0.
Mm-hmm.
You see how that's also a solution? But
Yeah.
you can't divide by 0. That's why the dividing by x gets rid of that x equals 0 solution. So I always say this, whenever you're dividing things to solve things algebraically, make sure the thing you're dividing by, that 0 isn't also a solution. Like if this thing was like x minus 3, for instance, you would want to check that is x equal to 3 also a solution. Okay.
Mm-hmm.
So right off the bat, here, yeah, if x is 0, right? 0 equals 0, so 0 is a solution. Okay. That's one that works.
Okay.
All right. But then let's keep dividing by x. So now I have pi x is equal to, so pi x sine of pi x is equal to 2 cosine of pi x. What do you think I do next here?
Uh,
Kind of a weird one, isn't it? Yeah, this is very weird.
just plug random values.
No, we don't need to do that. No. Here's what I'm going to do. I'm going to move... I'm going to move this over here. I'm going to move this over here. So I'm going to have pi over 2x is equal to cosine of pi x over sine of pi x. Do you know what cosine over sine is?
Tangent.
Cotangent.
Cotangent.
Sine over cosine is tangent. This is going to be cotangent of pi x. Okay? All right. We're getting closer. Okay, so wait. Pi over 2 is equal to the cotangent of pi x all over x. Ew. Is this solvable? I don't know. Rampton, do you know if this is solvable?
Sorry, which one?
Right here. If I get to here, I'm trying to solve for x.
1 second.
I know you're probably deep in the triangles.
Yeah, I'm like, if we get there, can we solve for x?
Yeah.
No.
No, right? Yeah, I was trying to think.
There's no analytic solution to
Yeah, there's no
this.
analytic solution to this. Okay. All right. Okay. That's fine. So yeah, so I think
Wait.
you do. What's up?
Wait, look at the problem says to find the number of C's. Wait. Go to the problem. The top.
Oh, estimate
says
the
estimate.
estimate the number of points. Oh. Tricky. Okay.
So which one?
Yeah, so he wants to figure. Yeah, I thought they wanted to. This is basically the mean value theorem, right? But they want to find the number of points. That's cool. That has to do with crossing points, is what that is.
Oh, the finding this, you can think about this visually actually.
Right.
So wait, I hope if this is the graph of cotan. So this is, let's think about this equation. That's better.
Yeah.
So cotan of x, that just looks like tan of x, right? But just shifted.
Shifted. It's vertical, right? Right. Or no, it's shifted by pi over 2, right?
It's like this, right?
Yeah.
Something like that.
Mm-hmm.
So that these are and then every pi over 2.
Yeah. And then the restriction on this is also that it's x can only go from -2 to 2. Is the other restriction.
-2 to 2, and then the graph of pi over 2x looks like this.
Oh, okay. This is cool. I like this. Yeah. The graphing
So
solution.
then, because this is negative, this would be wait, I just want to check the
Yeah. Check what like cotangent looks like.
graph of cot x looks like, oh, it's the other way around. Yeah. So it looks like this. Kind of like that.
Mm-hmm.
And then let's say that, we have the y-axis right down here. And then your solution is gonna pretty much, we're going from, what is it, -2 to 2?
-2 to 2, yeah.
-2 to 2. And then this is cotan of pi x, right? So typically, this will be at -pi, right?
Mm-hmm.
So, am I correct? Yeah. So this will be at, where's that? Oh, tab. There we go. So this will be at -pi, and then this will be at pi. But because we have cotan of pi x,
Right.
this is
Expanded out.
shrinking,
Yeah.
right, by a factor of pi, right?
Uh-huh.
So the reality is that this is actually just 1.
Yep.
And then there is another one
Going out to 2.
that happens here at 2.
Mm-hmm.
And this one happens at -1,
Yep.
and this one happens at -2. So you're gonna have 4 solutions.
Plus, yeah, 4 solutions, and then plus the 0 that we had from originally when we divided out by x. So, Bob, I think the answer is.
Okay.
I think the solution is 5, Bob.
Wait, where's the x that you divided by?
So originally,
Oh,
what
right here. Oh,
yeah,
this
exactly,
is-
right, yeah, exactly, yeah. And you can also, so this is really cool. So Ramta did something very cool here, where like he didn't even use a calculator, right? He just graphed this in his head, and this is why when you guys learn this in high school, like how to graph sine, cosine, tangent, and cotangent. That's where this comes in handy, because you can see I did it on the TI-84. Like I actually did the graph. I did the graph of cotangent and pi x, and then I did the graph of pi times x. But you don't need a calculator for this if you understand how to graph things, like in your head, kind of. But yeah, you can also see on the calculator, right? It does it. What is that? 1, 2, 3, 4 different times, plus the 0. So there should be 5 solutions there. Is that the correct answer there, Bob? You know? Or doesn't know if it's like, looks like it's a homework question. I think this is 5.
I'm not sure.
Okay, I think it's 5. Does that make sense though? Why it's 5?
Yeah.
Okay, cool. Here, I'll download this picture so you can have it.
Thank you.
You're very welcome, dude.
Nice.
Put it in there for Bob. All right, we're gonna get through everyone's questions today. Don't worry. It's Friday.
I think I figured out the other thing
Okay.
slightly, but I want to make sure that I have the full solution before
Okay.
we go back to.
All right, cool. All right, we'll get to that. Let me see. I think Slimy has a question as well. Let's see. And Habib has one. And okay, Slimy, you up here, dude? Where's Slimy? Slimy. On the stage. You on the stage? Yeah, you should be on the stage, right? Here. I'll tag him. Slimy wants to do his.
Hi.
Hey, Slimy, how's it going, dude? How's your Friday?
Good.
Nice. So this looks like an order of operations question. Do you know how to do this one?
Yeah.
Okay, show me how to do it.
Why do you think I told you to solve this question out?
Well, I want to see if you know how to solve it. That's the whole point here. We're trying to teach you guys.
No, I don't.
You don't?
I'm bad
Okay.
at the-
Well, here I'm gonna help you out here. Do you know about order of operations? Have you guys learned about that yet? Have you heard about this?
No.
PEMDAS?
Oh, yes, we have.
Oh wait, I did this wrong. Okay. So what this means is that you need to do parentheses first. You see any parentheses in here?
No.
Good.
Exponent.
Nope, no exponents. Okay, but we do see multiplication and division, right?
Yeah.
Okay, but we want to be we have cases of multiplication here, right? We got multiplication right here. We also have division here. These are technically the same priority, but we want to go left to right. So what thing are we going to do first?
We're gonna do multiply first.
Good. What am I going to multiply?
4 times 0.
Nice.
Good. So that's just 0. We don't care about that. What about the 3 divided by 3?
1.
Okay. So now I'm left with 10 minus 0 plus 1. Okay. What's the next step I got to do?
Minus. Wait, addition first. Addition first.
Well, no. These are the same priority, Slimy. It means I need to just go left to right. Okay?
Subtraction first.
Yes, you're going to do the subtraction first, okay? So I'm going to do 10 minus 0. What's 10 minus 0? Not 0. 10. Good. And then 10 plus 1 is what?
11.
Nice. Good job.
Nice. That's dope.
Make more sense, Slimy? Yeah?
Yeah.
Good. Congrats. All right. Roll through the next one. Habib has a question. Habib, what's going on, dude? How's your Friday? Good? I can almost hear you. Maybe boost your mic up a little bit.
Better.
Little more, a little louder.
I don't know how.
It's okay. Just if you talk really close to the mic like this, then I can really hear you.
Okay, cool.
There we go. Awesome. Which one do you help with, Habib?
The one that I put in.
Well, there's 3
Oh.
questions here. Or I guess, well, they all refer to the same one. Let's just run through them. You're good. Okay. All right. This is cool. This almost looks like an ACT question or something.
Yes.
Okay. So we have plots the velocity of galaxies relative to the Earth against the distances from Earth. That's cool. This is called a scatter plot, by the way. They call this a scatter plot when we have like a bunch of dots and stuff. Okay. And then what they're saying is that the data can be modeled by an equation, V is equal to 500D. Okay. This is called a linear approximation, or sorry, a linear regression is what it's called. And so what they're saying here, Habib, is that the data follows a graph that looks like this, kind of. This is the same graph. V is equal to 500D. Do you understand how I made that graph? It's okay if you don't.
No.
Okay. Do we know y equals mx plus b? Right?
Yeah.
Okay. So in that case, right? M is the what?
The
Slope. And then b is the
y-intercept.
good. The y-intercept is just like where it hits the y-axis, right? The y-axis would be this, okay? So our equation here, right? Do you see how this looks like very similar, right? We got the v, which is basically y, right? And then we have the d, which is basically x, right? So that tells me that what is m going to be? What's the slope going to be?
500.
Good. And then what is the y-intercept going to be?
Doesn't intersect with y.
Well, it doesn't have a number, so this can be plus
Wait,
0. It can be plus 0. You see how if like I don't have anything, it's the same thing as saying plus 0?
There's something, isn't there?
No, it just says v equals 500d, right?
Oh, okay, you're going off that. Okay, yeah, okay.
Yeah?
Cool, okay.
You're
Yeah.
probably seeing this, right? Is what you're seeing? Okay, yeah, because the problem is like this is 0. They don't make this 0, they make this 0.
Yeah.
Okay. So, if I graph this, right? Intercept being 0 means I'm going to put a point at 0, 0, right? Because that's where it intersects, right? The y-axis intersects right here at y equals 0.
0 is, 1.
Good. And then a slope of 500 means what? Let's remember what slope is, right? Remember how slope is like change in y over change in x? Or we say like rise over run?
So 500 up and over 1.
Good. Do you see how this is already 500 up, just going up one step? And then going over 1 would be going to here, right? Going from minus 0.5 to 0.5, that's a change of 1.
Yeah.
Right? So here's my other point, right? Okay. So then I can draw a line in between these two, and it's going to look something like that. Okay?
Okay, cool.
Cool. That's the whatever, the relationship. Okay. So it says, according to Hubble's data, okay, so according to the data here, in meters per second, is Galaxy Q moving away from Earth? Okay. So Q here, right? This is Galaxy Q. Or they say how fast is it moving away from Earth? How do we figure out how fast it's moving?
Velocity.
Good. We look at the velocity, right? So this is important. You know, this is how to read a graph, right? Okay. So here's Galaxy Q. So I'm gonna like draw some lines where it intersects, right? Okay. So what's the velocity of Galaxy Q?
500.
500, right? You see how that's 500 here? The distance is 2, right? You see how that point corresponds to a distance of 2?
Yeah.
Okay. So, and this is where they try to screw you up, because it's 500 kilometers per second. What are all the units here?
Meters per second.
Meters, good. So you need to convert between these two. Do you know how to convert kilometers to meters?
Divide by 100.
Not quite. So 1 kilometer is equal to 1,000 meters. Okay.
Yeah.
You ever seen that? Like, you ever run track or anything? You ever run track? I don't know.
Well, we don't use kilometers, but.
Well, oh really? In track, what do you guys? Oh, use meters, probably right?
Yeah.
Yeah. So, for instance, like, you know, when you do the 1 mile race, it's 1,600 meters because it's 4 times around a 400 meter track, right?
Yeah.
That's 1.6.
Yeah.
Yeah, that's 1.6 kilometers. Where that comes into. You can also think of like kilo. You ever heard someone be like, "Oh yeah, man, I just spent 8K for that car," right? How much money did they spend if they spent 8K?
8,000.
8,000. Good. So that's where kilo comes from, right? You know, if you're a drug dealer, you know, kilos of drugs are also a thing, but don't be a drug dealer. So yes. So that's why a kilometer is 1,000 meters. So remember all those rap lyrics or something, you know, if, you know, you forget like how it works, you know. Kilos is more 1,000. Okay. So if I want to write 500 kilometers per second as meters per second, what do I need to do?
You have to multiply.
Good. If you're ever confused what you need to do, or you can always do, have you done stoichiometry before, Habib?
Sorry, what?
Stoichiometry. Have you done chemistry?
Yes.
Okay.
Chemistry, yeah.
Have you done like units conversion before?
Oh, yeah, of course.
Okay, good.
It's just
All right.
multiplication or division.
If I want to know how many meters are equal to 500 kilometers, what you do is you multiply by what's called like a scale factor, which is
1,000.
good. it's going to be 1,000 meters on the top, right, is 1 kilometer, right? See how these are going to cancel?
Yeah.
That's why it's 500 times 1,000, okay? So 500 times 1,000, that's the same thing as 500,000, right?
Yeah.
Okay, but this is not in, they want things in scientific notation. Do you know how to get this into scientific notation?
Uh.
I know, this one's always tough.
Never done it.
Okay, it's all right. So what happens is, so here's the decimal, right? But I want the decimal to be over here, right? So it has to go 1, 2, 3, 4, 5 places over, okay?
Would it
Right.
be 10 to the 5th?
Good, yes. Anytime you need to move the decimal to the left, you got to move the exponent up, okay? I forget, it's like up, left, and like down is to the right. Yeah, that's what I call it. I call it LURD. LURD. It's like a weird acronym or something. But this means left, right, goes up, right goes down. Okay?
Yeah.
So this is going to be 5 times 10 to the 5th. Okay? Good? Yes. Good. Good, good, good. Do you see how that's an answer choice right here?
Yeah.
Good. All right. Let's go real quickly. There are 4 galaxies shown in the graph with approximately 0.9 milliparsecs from Earth. Which of the following is closest to the range of velocities of these 4 galaxies? Okay. So they're talking about the ones that are 0.9, right? That's going to be these ones, like right here. You see how this is like basically 0.9 right here?
Yeah, like 1 and 0.9.
Okay. So let's look at the range of velocities, right? So we got from 0 up to what? What's that? Like 700, 750 probably? So that's why the range of this, right, is going to be around 700. You see that?
Yeah, okay, yeah. No, I was looking at the wrong thing, but yeah.
All good, all good. Okay. Based on the model, what is the velocity in kilometers per second of a galaxy that is 15 milliparsecs from Earth? Okay.
So,
Or megaparsecs, not milliparsecs. Sorry, I've been saying it wrong. So they want you, based on the model, that means they want you to use this equation, Habib. They want you to use V is equal to 500D. And they tell you here that, like, you know, velocity is in kilometers per second. Distance, right, is in megaparsecs, okay? And that's what they give you here, right? Do you see how they give you 15 for the distance here? And it's already in the correct units. It's in megaparsecs. So we just got to plug this in. So we get V is equal to 500 times 15, okay? This looks like a scary number, right, to do, right? I don't like this, right? We're just like, oh no.
I mean, 5.
Good. So here's how I would do it. This is kind of like a cool little trick I do. So I'm going to do 500 times 10, and then I'm going to add 500 times 5. This is the same thing as 500 times 15. I'm breaking this up into 2 parts. Okay. 500 times 10, you should know what that is. What happens when I just multiply something by 10? What do I do with the zeros? Add another one, right? Yeah, good. So that's 5,000. Okay. 5 times 500 might be a little hard to do, but like, you know what 5 times 5 is? What's 5 times 5?
25. And then
25.
Add the 0.
Add the 2 zeros. Good, yeah. So this is 2,500. So 5,000 plus 2,500 is what?
7,500.
Good, 7,500. Nice.
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 Nice! Does that make more sense? More sense to you, Habib?
Yes. Yes, it does.
Yes, it does. Okay, I'm glad, dude. Welcome back to the server. Always good to have you around, dude. You know.
I figured out the other problem. It was just I was making it too complicated.
Hey, right?
I mean, it doesn't need all of that information because pretty much what I was doing.
Do you want to show it? Do you want to show it? Do you want to show it to us?
Yeah.
Here. Do you want me to, here?
What I
Let me
was
clear
doing-
this for you. Let me clear this for you.
Just clear it, yeah. Because what I ended up doing eventually just gave me 1/2 equals 1/2.
Oh no, dude! I love that when you write out all these beautiful expressions and then you get basically like 2 equals 2.
Yeah, it's not that complicated.
All right,
You know,
let's
it's
see.
just-
Show me
it's-
how
as
it's
I
not
said,
that complicated.
It's about finding the right way of doing this problem. Okay, so the key information we need is that AP is equals to TB
Mm-hmm.
is equals to SQ.
Okay.
All right. So what you want to do is you can find AP by pretty much just this whole side being 2. That's it. You don't.
Yeah, right. That whole side is 3. That whole side is 4.
4. Okay.
Okay.
So XY. God, I can't write.
It's
XY
okay.
is equals to AX plus AP plus PY.
Okay.
Okay. So AX is also equals to SM.
Because it's a parallelogram.
AP plus PY equals to TM.
Okay.
Okay. So now all we have to do is write a ratio of TM to TB. So TM over TB
Is 2 or 3.
over 3.
Right, because we got this triangle and then we got this triangle.
TM equals to 2 over 3 TB. But look, TB is equals to AP. So this is also 2/3 AP. Now, similarly for SM, we would write SM over SQ, which is 2 over 4 or 1/2. So SM is equals to 1/2 SQ, but also as given in the problem, SQ is AP as well.
I like that. I like that.
So then you just get 1/2 AP plus AP plus 2/3 AP.
Nice.
And this was equal to side XY
Yes.
to 2. So there's more than one way. You could have just taken the side, broken down the side X and then figure out BZ and YT. So there's like more than like one relationship that you could have like put together.
I see.
But yeah, 2. And then to get these, we put the AP in front, which is the common factor. And then we get a common denominator, which is 6.
6, yeah.
3 over 6 plus 6 over 6 plus 4 over 6. This gives you 13 over 6. So AP is equals to 6 times 2 over 13, which is 12 over 13. There you go.
Nice, dude. Love it, dude. That was a tricky one, wasn't it, dude?
Yeah, it's just finding, as I said, I could see the solution, but I was like, I know what I need to do. just figuring out the right things, and because there's a lot of letters, it always messes with me. It's like you have to like figure out what letters were what.
Yeah, dude, that's a funny one. Damn. Wow.
But yeah,
good challenge question. Was that the answer there? Was that the answer, Ethan? Was that it? 12 or 13? All right, let's see. All right, Nick, we're going to do your last question of the day. Then we'll play some doors. Oh, my back's killing me.
Can I do that big-ass physics problem?
What big-ass physics problem? Oh, Shadows?
Shadows.
Yeah, I haven't seen him yet. I need Shadow to come back. When he comes, wait, we'll see if he shows up on Monday. I'll do it on Monday.
Okay. Yeah.
Also, when I have like more energy. We're already at an hour and a half, which I'm okay with, but at some point I'm tired. Okay. Sorry. A number is randomly selected from the set of all numbers where x is from that to that. What is the probability that the number will be greater than or equal to 1? This is a cool one. This is what is this? Is this a linear distribution or a constant distribution? Is that what we say, right? Yeah. Okay. Okay. So we're gonna have kind of cool. The 7/8, and then going all the way up to 4/3. And yes, they're all equally likely. Okay, cool. This is statistics, which Noise was doing statistics, I think, last night. He's like, I hate statistics. I think statistics is one of like the coolest thing. I guess it's technically probability, but statistics and probability is like, it's one of my favorite subjects actually. I agree it's annoying to like have to remember all the math with things, but like when do you use a t-test, when do you use a z-test. But the fact that like
Yeah.
we can quantify like certainty, like there's 100, like anything is possible, right? But then at some point we're like, okay, but what are we okay with saying it's basically not going to happen? You know?
I hate statistics because of statistical mechanics.
Ah, see, yeah, I didn't really get that far, I guess. StatMech, yeah, no, don't do that.
StatMech is my least favorite course. Pretty much, I talked to everyone who's taken StatMech,
Yeah.
and unless they took the undergrad one, they hated it. Even my profs. He was like,
Ah,
when
I
I
see.
took StatMech in undergrad, it was my least favorite course, and they was like, when I took it in grad course, I really loved it.
Interesting.
So I'm not the only one who feels that way about that
Okay,
course.
noise. If you're listening, dude, that's why, dude. It's okay. It's okay. So yeah, the way this one works here, Nick, is that there has to be 100% chance of something happening. So there has to be 100% chance of me picking a number between 7/8 and 4/3, which means if this was a graph of like the probability of a number versus a number, this area between 7/8 and 4/3 needs to be equal to 1. And this is a rectangle. So what I want to do is figure out like what the height of this rectangle is. Because if I know that, then I can find the area of a number being greater than 1, or the probability of a number being greater than 1, because it's just going to be the area of the rectangle that is greater than 1, which is just going to be this part. So first thing I got to do is I need to figure out what this height is. So the height times 4/3 minus 7/8, that has to be equal to 1. This is ugly. I'm too tired at this point to start doing fractions. So I'm just gonna use a calculator. Not that. Where is my calculator? There she is. Okay, cool. All right. So we're gonna do 4 divided by 3 minus 7 divided by 8. Good. We're gonna get that. I'm gonna do 1 divided by that. All right. And that's going to get me my height. Okay, cool. So h is equal to 2.18 repeating. I think it is. Yeah. All right. Awesome. Now, to find the probability that the number is greater than 1, I need the area of this rectangle from 1 to 4/3. So that probability there, so we write this as this. We say the probability that x is, and this goes actually way back to what Ripple was asking about inequalities. This is x is greater than or equal to 1, right? This is, see how the probability that x here is greater than or equal to 1, but also less than 4/3. But here, we'll just do, there is no probability that it's greater than 4/3 because we say that doesn't exist. This is going to be the height times this length, which is going to be 4/3 minus 1, which is 3/3. So that's just going to be equal to 1/3. So if I just multiply this by this, oh, I see. They put things in fractions. That's ugly, dude. What? Okay. Second answer times 1/3. I get that, 0.727. Let's see. I think the calculator can actually like convert this to a fraction. Let's see if it can. Aha, I can. Thank you, TI-84. 8/11ths, which is choice D. Nice. All right. Nice. Good question there, Nick. Okay. Yeah, that is super helpful because I didn't want to like convert that to a fraction. There is a way to do it using like multiply by 100 and like divide by it or something. We could do that at another point. That's a cool one. Why is Ethan server muted? There, Ethan. All right. Oh, something is still happening with your mic. Okay, I'm gonna go back to serving muting. All right. Cool. All right, that's it for office hours. Thank you everyone for coming by. How is Ramton drawing on the board? He has access to the board. So if you're a TA, you have access to the board. You can write stuff. Omega says, "Oh, can you let me up?" Oh. Well, Omega, you're quite late, dude. What? This is like an hour and 40 minutes after we started. Oh man. Here, let me give this to Dark. Yeah. Here, I'll let you up, but I can't do any more questions. I'm done. This has been an hour and 40 minutes. I can't do any more questions.
I was just about to ask one.
All right, ask it on Monday. Ask it on Monday. Ask it on Monday. I'm tired. I'm so tired. I've been doing this for an hour and 40 minutes.
Hey, I got a question for you.
Yeah, what's up? We're 40 minutes over. What's up, Ramton?
Oh,
I said I can answer if you want.
Yeah, okay. Yeah.
Question first, and then we can see.
What's your question? Yeah, what's your question first, Omega? What's your question?
The question is, can your dopamine receptors, can they be like
Dopamine receptors.
like-
I don't think any of us know about dopamine receptors. Well, I do, but for the wrong reasons.
yes, they,
when you
Yes,
have
they can.
can they be like ruptured if you ever have like, a
Yes.
stroke or something?
Oh, that's a cool question. That's a cool medical question. I actually have no clue about that because I'm not a doctor.
What was the question?
His question was like, can your dopamine receptors ever be like ruptured from like a stroke or something? So like basically you can never feel happiness again.
I'm pretty sure it can.
Yeah.
Yes, but no. It can like.
Yeah, it's like
dampen
I
the
know people
ability.
that have done too much cocaine and like they've probably ruptured their
No,
dopamine
I was just gonna
receptors.
say it can like dampen the amount it does, so it will still do it, but
Yeah,
just
you can
not
build
at the
resistance
level.
to it.
You can build resistance. Yeah, that's the thing. That
Yeah,
is.
I know that much. But talk to
It's
a
gonna be at a
neuroscientist.
decreased level.
Yeah, talk to a medical doctor. Well, I'll Google this actually. I'm curious, Omega. This is actually whatever.
It's yes, they can.
Can you damage your dopamine receptors?
Yes.
Oh, here we go. How prolonged? Oh, this is actually a cool thing. All right, we're gonna do a little education here. Dopamine has been considered a pleasure chemical. I do know that. Yeah, so it's kind of like you know what you also get a dopamine hit from whenever like you check your phone.
Caffeine.
You ever go on like Facebook and like you ever find yourself like constantly like scrolling and whatnot?
No.
That's literally like smashing the dopamine button like in your brain, which is not a good thing because as Ramton was saying, you can build up like a tolerance to that, where like you don't get like as high, like you don't get as like happiness or pleasure, I guess, from it. Drug use can result in an increase of dopamine in the brain. Yes, exactly. Yes, cocaine, lots of dopamine. Also, there we go. Eating, interacting with friends and loved ones, music and art, addictive drugs, and sex. Yeah, so, you know, some of these things are okay. Some of these things are not good for you. But here we go. Where's the addiction? Yeah, people get addicted to dopamine. Like, you know, again, that's why social media is what it is. Like, you're addicted to dopamine. Like, it's...
You could have good. I mean, I guess depending on what you consider as good addiction. But
Exercise. Exercise is a good, like, addiction,
Yeah,
right?
exactly. That's what I
Right.
was gonna say.
Yes. Yeah, alcohol's not good. Okay. Where's the healing, though? I want to know healing. Yes. Minimal dopamine include depression, anxiety, fogginess, fatigue, neuron damage, withdrawal, like all these bad things. But let's see, like, the heal. How long? Here we go. Healing takes time, blah, blah, blah. I just want, like, I want a number. Can I get a number, please?
I think it depends on.
Depends on how, like, fucked you are, basically, right? You know, it depends, like, how long you've been addicted to things, of course.
Yeah, but I know actually there is the idea of neuroplasticity.
Uh-huh. What is
Yeah,
neuroplasticity again? Sorry, remind me on that, Ramton.
It's your brain's pretty much adaptability to change. Like you can change your behavior, you can change
Okay.
your, like habits and all these stuff. And so like there's some chemical like stuff that could happen as well. Like your brain could just completely alter its like dynamics. I bought a cool book actually recently about it, but I haven't gotten to it yet. But
There's
yeah,
a-
once I
Yeah, post the book. I love like reading these things and whatnot. They call it also like kind of like biohacking, right? Where you're trying to like optimize things in your body and whatnot.
Yeah.
But yeah, so these are the four main ones that you'll probably hear about in these are like the brain chemicals. So there's dopamine, the one you just asked about, Omega. Yeah. This is the reward chemical. So this is like the pleasure of like, you're like, oh, I did something. And this is why exercise is a good one for dopamine because you're like, oh, I did something. I went to the gym. Like you feel good. Or if you do well on your homework, Eating food, I guess, is dopamine. Yeah, I like to eat food. Doing self-care activities, celebrating little wins. Yeah, dopamine's great. It's a reward chemical. The other one is Yeah, what's up, Ramton? Say it.
Yeah, one of the things that I also was gonna say, like sugar, like brain has really high sensitivity to sugar.
Yeah.
And I read this thing that like our brains are not evolved as the rest of us.
Yeah.
Like our
Like our gut
instinctive
biome and
parts of our
stuff.
brain. Yes. So the thing is like when you eat sugar, your brain has still from an evolutionary standpoint still has not caught up to the fact that we do have access to food on a regular basis.
Yeah.
So when you get sugar, the reason that you want more and more and more, because like sugar was a scarce resource when we were like primitive, but we have evolved too fast,
Too quickly.
So, like,
yes.
Yes, that's why we get sugar addiction.
This is also like this is a famous graph people have shown that we're like the reaction in your brain, how your brain responds to sugar is almost the same as cocaine. Like you are addicted to sugar. It's a problem in like the U.S. diet for sure.
Yeah.
Yeah, that's also a very cool concept topic there. Yeah. That like humans have only been around for what 300,000 years, right?
Yeah, 300,000.
300,000 years. Yeah, we had that whole thing about like the calendar, right? And then like it's like the last 20 seconds.
Hour.
Yes. So yeah, we haven't been around that long, and like evolutionary stuff takes a lot of time. Like this happens on like tens, 100,000s of years for like species to evolve in certain ways. And yeah, Ramton speaks to a very good point here of like our brain has not evolved to keep up with our ability to like mass produce like these drugs, you know, like sugar and processed carbs and whatnot. Like that stuff has only come around in like the last like 100 years, 50, 100 years. And our brain's just like, what the fuck? This is why there are a couple diets out there that people like to do. One's called paleo, for instance, which tries to mimic what we could only eat when we were like cavemen during like the Paleolithic times. And it's supposed to be better for you because it's more in tune with what your body is used to for a diet. So it's not a lot of refined things, not a lot of like sugar or like bread. It's like, so what did we eat as cavemen?
Lack of processed food, right?
Lack of processed food. Yeah.
Okay.
I think I don't even think like cheese and stuff is paleo. I think it's like it has to be like we were able to make it as cavemen. I do keto myself just because like sugar wrecks me, dude, and I have to like cut down on sugar, so I don't really eat much sugar.
Yeah, like I think my body like it's weird because like even though I do eat sugar, I can go like days without it. Like I don't get that much
the cravings.
Yeah. So I do like I try to minimize my sugar and carbs intake, especially when I'm not like working out or exercising.
Yeah, right. Yeah, it's best for you. The other one is oxytocin. That's the love drug. That's the one that you feel good like when you hug someone or you play with your dog, play with a baby, holding hands. That's like the good feeling one. That's another brain chemical. Serotonin. That's I think like happiness is serotonin. They say it's the mood stabilizer, but yeah, happiness is also very related to serotonin. So yeah, going out, seeing the sun. I know some of you guys just spend all day. I'm guilty of this too. I spend like all day inside sometimes because I'm just on the computer or whatnot, and like I forget to be like, I should go see some sunlight because seeing the sun actually does like make you happier. It releases chemicals in your brain that help with that. Meditating is good. Running is good. Being in nature, awesome. And then there are endorphins. Endorphins are also a cool chemical that you really get with exercising. And yeah, it kills the pain. Oh, see, this is where they say laughing. Remember I said like laughing is like the #1 key to things? Yeah, you just laugh at things.
Laughing is the best medicine is actually true.
It's actually true, yeah. No,
I think it releases like it does release endorphins.
It releases endorphins, yeah. Apparently dark chocolate and essential oils do too. That's cool.
So if I eat chocolate oil while I'm in chocolate oil.
Yes, awesome, dude. Cool. That's actually a cool question. I'm glad you asked that one, Hamega, dude. I'll give you a point, dude. That's cool. I learned something. You know, I didn't know that laughing was endorphins, but
I'm one off.
Yes. Cool. All right. Awesome. All right. Thanks again, everyone. Big shout out to Ramton for solving that massive triangle problem for us. I could not do that one. I would not be able to do it. I'm just like, no. My brain is fried at some point. All right. It was, you know, as much as it was like, it pained me, like it was pretty cool. Okay, let me see. Let me close this. All right, so what we're gonna do now, if you guys want to keep hanging around, we're gonna do some Roblox. Friday's Roblox, Wednesday's Warzone, Monday is Fortnite. I think we're playing Doors. I think Ethan, we're playing Doors. We're playing super hard Doors or something. Is that what we're doing? There's like a level 200 or something. I might just sit back and just like watch you guys play, honestly. Yeah. It's okay. Okay, cool. All right, here we go. All right, I'm gonna raid the channel. All right, so thanks guys for showing up. Monday we stream again, but it's gonna be 2 hours earlier. So that's gonna be 3 o'clock Pacific, 5 o'clock Central, 6 p.m. Eastern. I may start doing more of the Jackbox games. I know you guys like that. Those are always fun. We'll see if I have some time this weekend to do it. Otherwise, we'll do them next weekend for sure. I'm still kind of recovering from COVID. Any other comments people want to say before we raid? Gold, what does your shirt say? Oh, it says Happy Forest. Happy Forest is what it says. I designed this shirt. It's like 2 hands with a love thing and an owl. It's part of my brand Gold Life. It's for a festival that I go to in June, which is a lot of fun. Cool. All right, we're raiding. If you guys want to keep hanging out, I'll catch y'all in recess. Otherwise, have a great weekend. Enjoy. Go see some sun. Go get some serotonin. Go chill out in the sun. And we'll see you on Monday. Peace. All right.